All right, in 13.2, we're going to graph square root graphs and their inverses. So we're going to go back to basically graphing our quadratics. Notice that what we're going to look at right here, we're going to graph a quadratic, just a regular parabola that's shifted up 2, but we're also going to graph its inverse on the same coordinate grid along with a line of symmetry. Now maybe you recall that when we did inverses, that means they fold along this imaginary line of symmetry. So if you want to pause the video and on your notes page go through and make this dotted line, the y equals x line on all the graphs, you can do that and then join me back for graphing. But now that we're going to graph this, so we're going to just do our basic quadratic that goes up 2. And remember with our quadratic, we'll go right 1, up 1, right 2, up 4. And then there's that line of symmetry down the middle. So we'll go over here. We'll go left 1, up 1, left 2, up 4. And then we'll draw on our curved lines. Now, if we're going to graph its inverse, the way we're going to get our points for the inverse is this. We switch the x and the y coordinates. So for instance, if the coordinates of my f of x, my original function, let's look at our coordinates for a second. All right, we have, what do we have? 0, 2. And then we have 1, 3. And we have 2, 6, right? And then on the other side, we had negative 1, 3. And then negative 2, 6. So these are the points that we plotted on the original function. So to get the inverse function, you don't have to write this out every time. I'm just showing you what happens. By definition, the inverse function, the x and y coordinates, these two values switch places. So for instance, where it was 0, 2, now x is 2 and y is 0. And at 1, 3, it switches to 3, 1. So it's going to 3, 1. And then 2, 6 flip-flops to 6, 2. And then 3, negative 1, and 6, negative 2. So they just follow that line of symmetry, but this time it's just going sideways. So now sit back and look at this. You have the original function, the f of x, and we abbreviate the inverse function by the f of negative 1 of x. So that's how we say that. Now, stop and think about this. Remember the definition of a function. No x values can be repeated, right? Another way to check that is that old vertical line test, right? So it works great on our blue one, the original function, but then when we transfer it to the inverse, we have to ask ourselves, look at that, it does not pass the vertical line test, so it is not a function. That's an issue. It is no longer a function. Okay, can't do it. So notice this note on your notes. A full quadratic has no inverse function, and why is that? Because it fails the vertical line test. So in order to graph a quadratic, the domain has to be restricted. So I can create the inverse. Now notice for a second, if you look at just one side of this quadratic, notice it looks like a square root function, right? This looks like a square root function. So from here on out, when we graph these quadratics, we're only going to graph one side of it, and we're going to be given a restriction like x is greater than 0, like just this side, or x is less than 0, or vice versa. So we're only going to be restricted to one side of the quadratic so that when we invert it, it is still a function. It's just now a square root function. Okay, so notice what it says to do in your assignment down here. It says graph the function and its inverse on the same coordinate grid along with a line of symmetry, which hopefully you've already done that. State the domain of the function and its inverse using set notation. So maybe make yourself a highlight on that. We're using set notation. That's the curly ones, right? The curly bars. So let's look at number 2. Okay, so as the instructions say, for each of these f of x functions and its inverses, we're going to be finding the domain and range for each of these. So I went ahead and wrote this part down on my paper just to have it, to make it easier. Now notice the way the question is written. It gives me the quadratic, but then this part right here is the restriction that we were talking about. Okay, this is the restriction, and this is saying where x is greater than 0. So this means I'm going to be graphing just the right side of the quadratic or the parabola. If you jump over and look at number 3, notice that the restriction says less than or equal to negative 3. Since it's a less than, we're going to be doing the left side. Now another way you can think about this is look at which way the inequality points. This one points to the right, so I'm just doing the right hand part of the parabola. Over on 3, it points to the left, so it's just the left side. So let's graph these and just see what happens on just the f of x, okay? I'll keep those in blue. So this one's x squared minus 4, so it's my vertex is going down 4, and I'm only doing the right side, so I'm going to go over 1, up 1, over 2, up 4. So it hits the x-axis, and there's my curve, all right? Now if I jump over to number 3, and let's just graph this one, the vertex is at negative 3. That's why the restriction starts at negative 3, by the way. So it's going less than, so that's the left side. So over 1, up 1, over 2, up 4. So it's just the left side of that quadratic, all right? Now, let's come back over here to number 2. Now if I label these, this is f of x, you should always label. Now let's look at the domain of number 2 here. Look, all the x values that we use are greater than or equal to 0. So it's greater than or equal to 0, just like the restriction stated it should be, okay? Now think about our y values. What's happening with our y values? The first y value it uses is this negative 4. So it's greater than or equal to negative 4. Now let's come back over here and do the domain and range of this one. On my x values for this original function, it starts at it goes to negative infinity, but it ends at negative 3. So that would be a less than or equal to negative 3. Again, it matches the restriction. The y value, the lowest y value is 0, and then it gets higher. So y is greater than or equal to 0. Now let's come back to number 2 and let's do the inverse, okay? Now you don't have to draw the table like I did before, but let's look at this. It's at 0, negative 4, right? And so if I flip that, I'm going to go right, negative 4, and 0. And this one is at 1, negative 3, so I'm going to go negative 3, 1. This one is at 2, 0, so I'm going to go at 0, 2. And drawn that curve. See how they just reflected along that diagonal? This is the inverse function of x, so I want to label. Now let's look at our domain and range here. What's happening with my x values? Well, my x's start at negative 4 and then they get higher. So it's greater than or equal to negative 4. My y values start at 0 and get higher, greater than or equal to 0. Okay? Now, let's jump over number 3 and do the inverse part of this one. So let's take it point by point. This first point was at negative 3, 0. So I'm going to switch it. I'm going to go negative 0, negative 3. This point over here was at negative 4, 1, so I'm going to go 1, negative 4. And this one was at negative 5, 4? 1, 2, 3, 4, and I go to negative 5. So my curve is doing this business. So let's look at our domain and range of that. My x value starts at 0, so it's greater than or equal to 0. My y value is lower, it gets lower and lower and lower, so the highest that it gets is negative 3. So it's less than or equal to negative 3. Now before I get off this graph, I want to label correctly. So this one's the f of x, and this is the inverse. So I want to make sure I have my correct labels on there. All right, now that we've done a couple of these, kind of lean back and look at the patterns. Noticing the patterns in this really will make this easier for you going forward. So take a minute and look for patterns in the domain and the range, in the graphs, and then meet me back just to see what they are. All right, so let's look at this. As we look at the right, when we graph the right side of the quadratic, this was this one, right? this is the right side of the quadratic. What kind of square root graph did it produce? Well, this is going in the positive direction. When we graph the left side, this made a reflected square root or a negative square root graph, right? So that will be a helpful pattern to follow. The right side of the quadratic produces a positive square root graph. And the left side, if you graph the left side, it will produce a negative square root graph. Now, also, I want you to notice the domain and range. If you look at this, your domain here matches the range on the inverse, and the range of the original matches the domain of the inverse. They flipped, right? They flipped here as well. Hopefully you saw that as it was happening. If not, it's a great thing to pick up on. So make this note, they flipped. Using these properties, these become a little bit easier to graph as we go along, okay? So let's try number 4. So my vertex is at positive 2 for my f of x, so positive 2. And we're going to just do what was pointing to the right, so I'm going on the right side. So I'm going to go over 1, up 1, over 2, up 4. So there's that. So I graph the right side, so it's going to be a positive square root graph. Now let me do the domain of this. X's are 0 and greater, just like the restriction says. My domain, what's happening with my y values? They start at positive 2 and then they go up. Y is greater than or equal to 2. All right, now let's do our inverted graph. So we went up 2 at 0. We're going to go over 2 and 0y. And then we go up 1 over 1, 2, 3, 4. So we see a positive square root graph going on there. So in our inverse function, all right, on our domain, we're going to say x such that x is greater than or equal to 2. It should match the range of the original, and does it? It sure does. So the range of my inverse should be 0 and above, and it is visually. So there you go. That's what you're going to do. Now let's jump over and do number 5. Let's look at our restriction. It goes less than, so that means I am graphing to the left. All right. Let's find our vertex. Our vertex is at -3, 4. 1, 2, 3, 4. I'm only graphing the left side, so I'm going to go over 1, up 1, over 2, up 4. So I'm just doing this side. So I'm going to have a negative square root on the inverse. So I guess I need to label my graphs better. Let's come back and do domain and range for the original function. X should be less than or equal to -3, just like the restriction stated. And as I check my graph, it is. Now range, I gotta stop and think about range. Lowest y value is that 4, so y is greater than or equal to 4. All right, now let's graph our inverse function. So this one was at -3, 4, so I'm going to go 4 down to -3. And it's going to go down, so I go down 1 over 1, down 2 over 4, because I know it's going to create the negative curve. And I'm going to label that with the inverse notation. All right, so let's do our domain and range. X is greater than or equal to -4. And my range, y, such that y is less than or equal to -3. They should match. Okay, so hopefully that shows you some patterns to make this graphing inverses of quadratics easier. Let me know what questions you have when you get to class.